Hi guys, welcome back to Differential Calculus. This is week 5 of our lessons from the beginning to until this point. Kaya pa ba? Nagsisimula pa lang tayo. Actually, this is the finally, this will be the point where I will be introducing to you the concept of derivative. So, simulan natin. By definition, the derivative can be used to determine the instantaneous rate of change or simply the rate of change of one variable with respect to another. And the process of finding the derivative of a function is called differentiation. So, dahil nabanggit ng term or ng definition na to yung derivative, let us talk about the specific word na that is rate of change. So when we say rate of change, ano yung unang pumapasok sa isip natin pag sinabing rate of change? It can be an increment. So pwedeng dumagdag, pwedeng biglang bumawas, pwedeng basta alam mong merong nabago. May nagbago definitely. And when we relate that to mathematics, so the main point of rate of change is finding, of course, the slope of a line. So by definition kasi ng slope of a line, so that is a rate of change between your vertical distance y with respect to the horizontal distance x. So by balikan natin konti ulit ang point is slope formula, that is y2 minus y1 over x2 minus x1 is equal to your slope. Okay, so now that I have also mentioned slope, let us try to consider this figure that I have here in this diagram. So let's say, for example, your first point to consider is this one, which is c and the function of c. So parang ang ibig sabihin, ang kaakibat niyan or equivalent lang din naman yan sa x mo and your y. So for example, any constant number or any constant point, hindi lang siya particular sa x and y, tawagin natin siyang c and function of c. So this is your c is your x and then f of c is your y, syempre. So ito yung point 1. So to find the slope or the rate of change from this point to, let's say, any point on this curve, not only on a line but on a curve. So consider the second point here as your point number 2. So meron kang point, wait lang, ayusin ko yung diagram. Meron kang point 1 dito, tapos meron kang point 2 dito. Gets ba naman? So there will definitely be a change kasi nag-displace yung second point mo at a distance of delta x, which denotes that there is a change in x direction going to the right. Tama? So we will denote the second point as c plus delta x as your x component kasi starting point mo nga itong c, nagdagdag ka ng delta x. So yun na yung pangalawa mong point, which is your x of 2. Okay, so evident naman siya dito sa figure. So x of 2 yan, while the second point naman along y is equivalent to, erisin ko para wala masyadong So kung dito ka nang galing, di ba? Ito yung origin mo. So f of c. So kung magdadagdag ako ngayon ng height, can I call that also delta y? Tama, di ba? So that is a change in the direction or height with regards to the y-axis. Okay, so that is correct. We can call that. But we will derive an equation that is equivalent also to this type of functionality. Taray. Okay, so try ko i-explain. Now, as I try to go higher at this point, so, na-erase. as I go higher, this y variable is now a function of x. So, tandaan nyo ha, lagi naman 'di ba, y is a function of x. As x goes up or goes here to the right, so malamang sa malamang umaakyat din yung y value mo kasi positive x yun. Unless otherwise negative, so papunta naman siya dito. So, ibig sabihin ko lang, may kaakibat na value yung x. Kapag sinubstitute mo siya sa x, may kaakibat yun na value din naman sa y. So, y is a function of x. So, if y is a function of x, then we can rewrite also this c as a function of c as your y component. And then, you can try to have this type of second variable for y2 as function of c plus delta x. Ibig sabihin lang nitong denotation na to, so itong x variable mo na c plus delta x, pag nag-substitute ko dyan ng any value of x, yun na rin yung kapartner na y value, which is now a function of x, and that cannot be that is an independent variable with regards to x's and y's, which I introduced from the beginning of the topic. So, sa makatuwid, ang x2 saka ang y2 ay ito na rin, c plus delta x, and then your y2 is a function of x, c plus delta x. So, ibig sabihin din, to get the y variable, so, to get the y height or y prime ay delta y, so delta y is just simply kung ilan to, diba dito if f of c, tapos kung ang height nito ay f of c plus delta x, so ang magiging delta y mo is simply f of c plus delta x minus f of c. So doon na derive yung formula nitong curve na to, regarding a function of c and then any number or any constant number as a function of that graph. So again, ulitin ko lang. Ito yung unang point mo, c, tapos yung function of c is your y. So we have x1 and y1. And then dito sa second point, so you have x2 and y2. Your x2 is now c plus delta x. Galing siya dito sa starting point, c plus delta x. So, magiging siyang c plus delta x. Tama? And then, yung y2 is now a function of your x. So, you can rewrite that as f of c plus delta x. And now that you have the two set of points, x2, y2, and y1, x1, so you can now relate this dimension as ito, delta x. Ito. Kasi yun yung change ng x direction. Ito namang y direction, so to get that, you will have to y2 minus y1. And then y2 is f of c plus x delta x minus y1 mo f of c. So kaya siya naging delta y. So tandaan nyo yung derivation. Anyway, this is just an explanation of the derivation of this point is slope form considering 2 points on a line or a curve. Okay, so now balik tayo sa main topic, which is the slope. So, slope is a rate of change, and if we are to relate the rate of change between y2 and y1, ayun, na-erase ko pa, no? So, ito yung x2, ito yung y2, ito yung x1 mo, and then this is your y1. So, y2 minus y1 will become f of c plus delta x. And then your y1 is your f of c. Tama? All over your x2 now is c plus delta x, and your x1 is simply c, so minus c, and then combine like terms, magiging lang siyang ito na f of c plus delta x minus f of c all over c minus c is cancelled out, so delta x, at yun na yung this one is the difference, This equation is the differential equation. the main formula for slope and differentiation is written just like this. F of c plus delta x minus f of c over delta x. Ganun kabongga. Okay, so ano pa? The right-hand side of this equation is a difference quotient. The denominator delta x is change in x, and the numerator delta y is the change in y. So, ibig sabihin, ang m is a change in y with respect to x, where x is this one, retained, and then your y delta, ito ay, ang triangle is read as delta. So, kung para paulit-ulit ako ng delta dito, triangle po yun. Baka malito kayo. Ano yung delta? Triangle. Anyway, okay. So, ito naman yung change in y, which is f of c plus delta x minus f of c. Okay. So, yun yung derivation. So, wala nang magtatanong kung paano na-derive. Nakakalito talaga siya actually. Okay, so now, let us, diba, any constant number yung nilagay ko for c. Pero if we are to consider x's and y's, so we have to go back to the main topic, which is a function of x plus delta x minus, pinalitan lang yung c ng x dito sa main formula natin over delta x. So this is now the formula for the derivative of f at x is like this. So dito magsisimula ang sakit ng ulo ng mga first year sa derivative. So yan yung taking also the function or the derivative of that function, i-relate din natin siya sa limits kasi ko-consider natin na ang limit of delta x as it approaches to 0 is sa substitute mo yung limit ng delta x sa bawat equation. Ang diskarte lang dito, parang limit, kailangan mo maka-cancel out ng factor of delta x both sa numerator saka sa denominator versus yung natitira mo dito. Say for example, x plus 3 plus or x squared plus 3, mga ganun bagay. So, ika-cancel out mo itong delta x dito sa magkabila para substitute mo na lang siya sa x squared plus 3 plus, say for example, may delta x ka. So, any number na may delta x is 0 kasi sa limits yan. And that is how you get the differentiation of an equation. So, without further ado, kahit naman magdaldal ako dito, hindi pa rin natin siya maiintindihan kung hindi natin siya i-apply on problem solving itself. So, let's try to find the derivative na. Okay, shall we?